Thank you for joining us for this.
Sorry.
Hi, 1 second, Scott, okay? I'll just read your bio and then we can get started with you. Thanks for joining us for this informative American Institute of Chemical Engineers webinar sponsored by Providence Consulting, Has PSI Become a Data Management Nightmare? Our speaker is Scott Kindy. Scott Kindy is a process safety management consultant at Providence Consulting. He has over 5 years of experience in PSM-related project execution in the oil and gas industry, and he has managed multiple projects related specifically to process safety information data management. He has expertise in project execution related to additional elements of PSM, including management of change, incident investigation, facility siting, process hazard analysis, and compliance auditing. He also has experience with the EPA Risk Management Plant Rule and the associated elements. One quick note before I turn the session over to Scott Kindy. As described more fully on this slide, the American Institute of Chemical Engineers assumes no legal liability or responsibility for the use or misuse of the content in this webinar. And now I give you Scott Kindy. Hi, Scott.
Hey, Pamela. Thank you. As Pamela said, my name is Scott Kindy. I work with Providence Consulting. Been in the PSM consultant business for the past almost 6 years. The projects I've worked on have had a strong focus on PSI management and management of change. So I really look forward to speaking to all of you about PSI management and the challenges and the solutions to those challenges that come along with it. So first of all, thanks to AICHE for putting all this together. Thank you specifically, Pamela, for all the help that you've given us this far. So to start the presentation, has PSI become a data management nightmare? So let me start by saying, what does that mean? I think before we answer the question, we need to consider what factors can contribute to a management nightmare, really in any facet of the business, and then look at how that specifically applies to the management of PSI. Factors that come to my mind would be things like inconsistencies, inefficiencies, duplicated efforts by employees or groups, missing information, misinformation, lost confidence, human error, all of these things. So as we start to go through this presentation, I challenge you to think about your own facilities. Think about the way that you manage things, your own systems, your document management systems, as we discuss the following. First, what is PSI? So we'll take an in-depth look at how OSHA defines PSI. I want you to consider how you define PSI at your facility. Then we'll take a look at why is management of PSI important. Things change in our industry day to day, right? Things are constantly changing, so management of PSI is constantly an important thing. And then we'll take a look at the elements of an ideal PSI management system. Those elements include consistency and accuracy. We all want to be accurate and we all want to be consistent, but how do we achieve those things? Well, consistency can be achieved through integration. Accuracy we can achieve through traceability to reliable documentation. And then we'll take a look at some pitfalls associated with PSI management. What are the challenges that come along with trying to achieve consistency and accuracy? And most importantly, we'll take a look at some solutions for overcoming these pitfalls. And then at the end, we'll go through a few slides to discuss a software that was designed specifically to help you overcome these pitfalls with regard to PSI management, called the Asset and Records Traceability System, or ARTS. First, what is PSI? Process Safety Information, or PSI, is an element of the OSHA Process Safety Management, or PSM standard. To summarize how OSHA defines it, facilities covered by the PSM rule shall compile written PSI to enable all involved in operating a process to identify and understand the hazards posed by the process. So the intent of Process Safety Information is to help everyone that's involved in operating these covered processes to understand the hazards that are posed to them. What is PSI specifically? So this is how OSHA specifically defines PSI. It consists of information pertaining to the following. The first is the hazards of the chemicals used or produced by a process. The second would be the information pertaining to the technology of that process. And the third would be the information pertaining to the equipment within the process. So we first consider what's in the process, then we would consider how does that process work, and then finally, what is the equipment that's facilitating that. So for the hazardous chemicals, we consider things like toxicity information, permissible exposure limits, physical data, reactivity data, things that you would find on a safety data sheet, corrosivity data, thermal and chemical stability data, and the hazardous effects of the inadvertent mixing of these materials. Then we consider the process technology. So that would be things like a block flow diagram, a simplified PFD or process flow diagram that shows how the process flows from beginning to end. The process chemistry, the maximum intended inventory. What do you keep at your facility? How much of it do you keep? This helps you determine, are you covered by the PSM standard? It also considers the safe upper and lower limits for items like temperatures, pressures, flows, compositions, and an evaluation of the consequences of deviations, including those affecting the safety and health of employees. And then finally, we discuss the equipment. So we've looked at the chemicals, the technology, now the equipment. OSHA defines PSI with regard to equipment as materials of construction, P&IDs, piping and instrument diagrams, which would be a more detailed version of your process flow diagrams, showing the equipment specifically, the instrumentation related to it, the electrical classification, the relief system design and design basis for that equipment, ventilation system design for buildings in electrical classified areas where they could be exposed to toxic hazards. We consider design codes and standards that are employed in designing and making that equipment. Then the material and energy balances, safety systems, such as interlocks, detection or suppression systems, and Aggregation. So it's important to consider all of this information. So I read through it just to iterate the point that there's so much information that's required for a process, and all of it must be valid not only upon initial commissioning or project completion, but we must also manage changes accordingly. So this is day-to-day changes, projects that happen down the line, and mismanagement of project handovers or day-to-day changes can lead to a data management nightmare. So as we look at all this, I challenge you to think about where your facility maintains this information. Is it available in a central location? Do you maintain it electronically? Do you maintain it in hard copy form? Do you have books of P&IDs that are kept in a central control room? Or do you keep them in an electronic database? And when a change occurs, are you confident that this information is updated accurately and consistently in all of those locations? So now we'll take a look at PSI as it pertains to a single piece of equipment. So we'll follow this piece of equipment from design to decommissioning, and we'll consider the PSI that's maintained in the data systems, but also in the documentation associated with this equipment. So of course, the beginning of a piece of equipment begins with design. So at that time, you've got systems that manage that design. You've got design software that's going to contain information. You're going to do an initial process hazard analysis on that design. It's also going to contain some PSI. You may have a relief system database containing different points of PSI. In the documentation associated with that, you're going to have design calculations. You're going to have spec sheets, performance curves, vendor drawings, and so on. From design, we move into commissioning. So once the design has been approved, we move to commission that piece of equipment. There's going to be not only more data systems, but more documentation associated with it. Of course, we're going to have to maintain that piece of equipment. So we're going to have some maintenance management software. Again, we're still going to continue to have this relief system database where we're maintaining this information now. We're going to put that equipment on a P&ID. That P&ID is going to contain some data points for PSI. We're going to put it in an inspection database. That piece of equipment is likely going to be expected for the rest of its life. We're also going to put it in some kind of document management system. So how are your P&IDs managed? How do you manage the documents associated with this equipment? And it's likely going to go on a plot plan for your facility. The documentation associated with it at that point would be things like a manufacturer data report, a nameplate, inspection reports, test reports. So not only things that we would get from the manufacturers, but also things that you would do at the site, like MOC documentation. You're going to manage the change of commissioning a new piece of equipment. And for sure, at some point, that equipment will be maintained, but we can all bet that it will be modified at some point as well. We all have projects that occur. Things maybe don't work the way we thought they would when we designed them. We improve designs, standards change. There's always a time that we're going to modify a piece of equipment. So first of all, we've got our maintenance management software again. We've got our relief system database, P&IDs. All of these things need to be changed as we maintain and modify this piece of equipment. When we do modify something, let's say we re-rate it, we're going to have a re-rate tag associated with that. So there's documentation that occurs with our modifications as well. We're going to have a repair or alteration report associated with maintenance or modifications. And of course, you're going to manage the change of modifying this equipment. And then when we get to the end of this equipment's life, we've got a decommission phase. Again, we've got all of these systems that need to be managed not only through commissioning, through maintenance and modification, but through decommissioning this. The PHA database, right? It's no longer valid in our PHA. We need to take it out of all the other systems that we've talked about, and we need to do an MOC to decommission that. So why is PSI management important? I think we've hit on it in discussing what PSI management is and what PSI is. First of all, PSI is a foundational element which all of the facility's risk-based and engineering decisions are made. Process failures we often identify as the cause of an incident, but PSI management failure is often at the foundation. For instance, a design failure, that equals an error in new equipment. A management of change process failure equals a PSI error in existing equipment. And I'm sure we've all seen that happen. We're not all perfect. We don't manage change as well as we should in every case, so we definitely are susceptible to PSI errors in existing equipment. And then risk evaluation and mitigation oversight, so like a PHA oversight. That could be equal to a PSI inconsistency. To talk about changes in particular, PSI changes must be managed in conjunction with process changes at a facility. So we've hit on this, but let's consider a new pressure vessel. And let's think about all the elements of PSI that could potentially be affected by the addition of a pressure vessel. The highly hazardous chemicals involved in that. A block flow diagram, or PFD, right? Process chemistry, maximum intended inventory, what's going in this vessel. The safe upper and lower limits for temperatures, pressures, and so on. All of these things have to be considered when adding a new vessel. The materials of construction, right? We need to consider those. We need to document those. It's going to go on a P&ID. We need to consider the effects it has on an electrical classification and update our documentation accordingly. And we need to consider the release systems for that pressure vessel. It's no doubt going to have other equipment associated with it, maybe a PSV is associated with it. We've got design and design bases that go into that. So that considers a new vessel, but what about a change, such as a re-rate? So now that we've got a new vessel, it may go through part of its life, and we need to modify it. We need to change it. It gets re-rated for one reason or another. Again, these same systems are going to be affected. We need to consider the changes that has on the PFD. We need to consider the changes that has on a P&ID. Also on the relief system design and the design basis. And the material and energy balances. So you can see through the management of change process, it could be easy to miss one of these through all of this. Maybe we realized that it changed our P&ID, but we didn't think about the effects that that has on our PFD. So now let's talk about, now that we've talked about what PSI is, why it's important, let's talk about the elements of an ideal system to manage that. Really, the two main elements would be consistency and accuracy. We all want accuracy, and we want it to be consistent across all of our systems. So how do we achieve those things? We achieve consistency through integration. We achieve accuracy through traceability. So integration would mean things are stored and maintained in one location. Traceability would mean we can relate things back to some sort of reliable documentation to let us know that we're accurate. So let's talk about these specifically. Consistency. Consistency would enable each department system to use the same PSI. This would mean calculations across the board would be based on the same data. We wouldn't have one group basing calculations on a set of data that maybe they maintain that's inconsistent with the set of data that the engineering department maintains. There would be no need to cross-reference systems if everything is consistent. This would also enable each system to leverage other systems to fill in gaps. So if we know we have a really strong inspection data management system, do we leverage that to fill in the gaps that we have in our P&IDs? In order to achieve this, let's talk about integration. This maintains consistency over time. This means systems are linked to each other. So this would tell us we do have a strong inspection data management system. If we can link it to our P&IDs and centralize that, we could tell that we don't have strong P&IDs. Maybe we can tie the two together, be consistent across the board, maintain the same information on P&IDs that we do in this other system. As you could guess, this would increase efficiency. If we know that we can go to one system and we know that that information is consistent across the board with our other systems, then we don't have to cross-check every time we want to do some sort of risk analysis, every time we want to design a change. And this would mean only one validation effort is required between systems. So if things remain consistent, we don't need to revalidate. This would also increase the accessibility of PSI. If all PSI is maintained in a central location, we can help maintain our consistency over time. We do this by reporting across those systems, right? Just like we said. So if everything is in a central location, we know that this program's strong, this one's weak. Let's report, let's keep reporting and keep those things consistent. And then we talked about accuracy. This is arguably the most important part because if your data isn't accurate, then everything you do is going to be errant in some way. So this means we achieve accuracy by validating PSI with reliable sources. So our documentation ultimately tells us what is accurate, right? Documentation that's provided with the equipment, and also field verification. So field verification of nameplates that has specific PSI on it. That lets us know this is reliable. This has been as built. This ensures that when we do a risk analysis based on equipment conditions, we know that these are the as-built conditions. Correct PSI ensures a correct risk analysis. This also ensures that when we make engineering calculations and when we design, that we're doing it with correct data. Of course, that's the most important part. Traceability helps us maintain this. PSI, if it's linked to a validating source, then we have confidence. We can trace our accuracy back to that validating source. This would increase our confidence in the data, but also it's going to increase efficiency. Like we talked about earlier, if I know I can go to this source and I can trace that source back to a reliable documentation, I don't have to cross-reference between these sources each time. So now let's talk about some pitfalls, right? We've looked at what an ideal system should look like. But now let's look at the reality of things and discuss some challenges, some pitfalls that come with how we manage our PSI. PSI resides in multiple systems and applications across many departments. I'd challenge you to think about your own facility, as we talked about earlier. Where do you manage all of this information? Is it in a central location? Does one department manage it? Or is it in multiple applications? Do multiple departments manage that information? For instance, you may have an inspection department that has a specific inspection data management system. You may have a PSM department that manages your P&IDs and PFDs and plot plans. An engineering department that has a separate database for doing relief device studies. A maintenance department that keeps equipment inventory lists for maintenance reasons in a separate database. And a document management department that keeps records, potentially separated from all of the data sources we just discussed. Not only do we have different systems, we have different departments. And departments tend to manage and maintain PSI separately. Verified data and information in one system is rarely leveraged to improve other systems. So as we talked about, when we recognize deficiencies in one system, when we make those corrections, do we tie the other systems to that? Do we make a change to our inspection database and realize we should check our P&IDs also? Should we check our PFDs to see if this information exists here? Or do we focus purely on our departmental responsibilities? If we don't, a number of redundant efforts could be made. So you could have a huge inspection department effort to update their systems, and then a year later realize your P&IDs are out of shape and have a huge PSM or engineering effort to update your P&IDs. The key would be to recognize these by centralizing your data and only doing these efforts one time. And again, documentation, which is the source of most PSI, is often maintained separately. So think about your document management systems. Is it maintained with your PSI? Can you get it all out in one location? Can you trace your PSI back to documents very easily? And another challenge, whether we like it or not, is human error. Right? Employees are all fallible. Management or change process is not without room for error. This error could come from the improper evaluation by an MOC team of the effect of a change on a particular system. So you may have an evaluation team that recognizes a change will affect a P&ID, but they don't recognize that change will affect a PFD. Or they don't recognize that change affected your release system software. Even if you have a flawless team, right, as information goes into those systems, we still have the opportunity for error. Could it be a typo? Could a person see an MAWP of 150 and accidentally type in 120? This happens every day. And it could also be neglect or simple forgetfulness by a system administrator to complete an assignment. So maybe you have a great MOC system and great MOC teams that assign the right things to the right people, and maybe sometimes an action item gets closed out by the wrong person and never gets tracked by the person it should have to put in the data. Maybe someone with good intentions puts something off till it falls off their radar and gets neglected. All of these pitfalls and challenges can lead us to a lost confidence in the validity of our PSI. And when we start to lose confidence, we lose efficiency, we lose the ability to design correctly. So if you've ever asked these questions, how do I know every vessel exists in all the required systems? How do I know every vessel's MAWP and MAWT stored in each system is consistent and accurate? How do I know every PSV set pressure stored in each system is consistent and accurate? Have you ever heard, maybe at your facility, yeah, I'm sure the P&ID says that, but we really need to go to the relief system software if we really want to know what this MAWP is. We can't trust those P&IDs. Or, yeah, we don't know how well that inspection database is maintained, so let's not use that information. Let's go back to the P&ID. That's the only place where we can find this. And I'm sure you've heard it before. It's a common occurrence. An example of the pitfalls associated with managing PSI would be re-rating a vessel. So let's say a vessel has an original MAWP of 226. That vessel gets re-rated to 150. Inspection system gets updated. But the release systems, for one reason or another, right, it could be any of the reasons we talked about to this point, does not get updated. Was it a failure in the MOC? Was it a failure by the administrator that was supposed to enter the data? Was it the MOC team? Who knows? It could be any of those things. So then the vessel is going to be expected to withstand a pressure that is lower than the relief pressure. So PSI discrepancies can go unnoticed if there's not a process in place to connect and cross-check these values. So now we get to the solutions. We've talked about what PSI is, why management of that PSI is important, what an ideal system would look like, the challenges associated with it. What are the solutions to those challenges? Well, we need to think about our information differently. We need to think about the interconnection between data, documents, and systems. Data is validated and traceable through reliable documentation. Data systems contain data. Do they contain the documents as well? Are these separate systems? Is there the opportunity to combine these systems? Can we have our documentation available right with our data? Documents, again, it's going to demonstrate the accuracy of your equipment data. And your systems, when thinking about these things, improve PSI maintenance without changing our existing practices. Can we centralize things where we can still update the systems we've been updating, but can we view those systems in a central location that allows us to see, are we doing it consistently without drastically changing what we do? One potential solution for this is a software designed specifically for it. It's the Asset and Records Traceability System, or ARTS. It's a software capable of compiling and cross-checking all of the facility's existing applications against each other. And the next few slides, we'll take some screenshots and we'll see how this looks and how it works. First, what is ARTS? It's a web-based application. It's a software designed to aggregate equipment information from multiple data repositories. So we've talked about this all the way through. How do we get all of our different systems aggregated to show what's in this system is accurate or is consistent with what's in our other system? It also aggregates reliable documentation. So it allows us to trace our information from all of those systems back to the documentation. It allows us to validate data from reliable documentation, right? So we can show validated data compared with unvalidated data. Does this data point have documentation associated with it that shows me this is valid, or does it not? Am I missing documentation? And it allows us to identify deficiencies and discrepancies easily. By comparing systems on one screen right in front of us, we can see, is this system deficient? Is it missing data? Is this system discrepant? Does it have errant data in it that my other systems show correctly? And it also allows us to track changes with each of these repositories. Most importantly, we can report on this data, report discrepancies, report trends. So not only does it allow you to identify the problems that you have, the deficiencies, the discrepancies, but it will allow you to report on them as you start to address them. First of all, we've got data aggregation. This is what the first step in solving our problems of integrating our systems, right, is getting our data into one spot. We'll use some examples here of different softwares. You may use these, you may not. Consider maybe what you use at your facility. Is it SAP, Maximo, UltraPot, PCMS, PPM, PNIDs, PFDs, and so on? What ARTS will allow you to do is aggregate the data from each of these systems in a screen like you see on this slide that allows you to do some easy comparisons visually. You can update this data on a regular basis. Do you want to update this data monthly? Do you want to update it bi-monthly, every 6 months, more than 2 or 3 times a month? It depends on where your facility's at in your management or change process. And then you can do a data comparison. So you want to aggregate the data to make this possible. ARTS has the functionality to automatically identify some deficiencies. This would be missing records or data, and some discrepancies. So data that is different in one system than it is in another system. Data can be transformed into a specific format to allow all data sources to be compared equally. So these are some things that are done on the back end because in one system your data may be formatted one way and another system may be formatted another way. So all of these things make it easier when you pull it in to do some automatic comparisons. Attribute discrepancies and deficiencies are flagged with the X and the O that you see there. So a deficiency would be an X. That means I don't have the data. Deficient records, meaning a whole data source. So I may have a piece of equipment that shows up in 4 out of my 5 data sources, but it's not on a plot plan. That's just going to show up as blanks. So we talked about data aggregation and comparison. We also want to talk about documentation aggregation. So this is what allows us to the traceability that we've been talking about this entire time. We aggregate our reliable documentation, so we are able to trace our data back to this documentation and call it validated. This documentation might include data reports, flow curves, nameplates, and so on. We can import these documents from other document management systems directly into this system. So you can look at your data sources, your data points, but go to the next page and find all of your documentation right there with it. So we're not going and looking at data electronically and trying to validate it by going to maybe a hard file that we keep in our vault and comparing the data to make sure it's validated. We can do it all right here in one centralized location. We can also import field pictures of equipment. So not only do we want accurate documentation, we want to be able to link back to documentation. We want to know what's as-built, what's in the field. We can take physical pictures of something to tell us, yes, we know this is out there. That's why it's on a plot plan. It may not be on your P&ID, it may not be connected to process, but we have a picture of it validating that it exists. We have a nameplate picture showing us what the MAWP of this vessel is. Data validation and traceability. So validating engineering data from reliable documentation. This is what it looks like in ARTS. So if I've got an MAWP that's validated, a check mark will show that it is tied back, it is traceable. We can tie it back to a nameplate. We can tie it back to a spec sheet. If it's not validated, you'll see the exclamatory mark there that shows us, yes, this is the data we think it is, but we don't have a source to validate this data on. Maybe that equipment doesn't have a nameplate. Maybe that equipment, maybe we lost the spec sheets years ago, and we've never had it, as long as we can remember. Well, we know what the data should be. We know what the value should be, but we can't validate it. This lets us know we've got some actions to take to make sure we get this data validated, that we're not making engineering decisions and risk decisions based on data that we do not know for sure. And finally, tracking and reporting. So not only do we want to aggregate our data, we want to be able to validate our data, we want to be able to aggregate our documentation to do so, but we want to be able to track progress. So the tracking and reporting functions will allow you to track changes within each data repository. So the equipment itself is inert, but the plant as a whole is dynamic. As data sources update their data, add or remove equipment, discrepancies are created. So as we manage our change, as we update one system and maybe not the other, these data sources are constantly changing. These reporting functions will allow you to identify trends. Are we constantly updating our P&IDs but missing our inspection documentation? Are we doing a real good job of updating our inspection stuff but we're not keeping our release systems database up to date? By generating reports on a monthly or weekly basis, you're able to identify these trends. These reports can include discrepancy reports that show you data points that don't match. They could be documentation reports. What do I have good documentation for, and what am I missing documentation for? Maybe you'll determine we've got really good documentation on our pressure vessels, but we historically didn't do a good job of maintaining documentation for PSVs. These reports will allow you to see that and allow you to think about where your site can improve specifically, maybe put together projects to improve those certain things. And trending, to show you, again, like we talked about, as we manage our change, what are we not doing well and what are we doing well? What can we learn from the folks at our site that are doing things really well? So in conclusion, we talked about PSI as the foundation of all of the facility's risk-based and engineering decisions. It's going to continue to reside in multiple systems. There is no perfect system to date that can do release system calculations that maybe is good for MOCs, maybe is good for all of your equipment information for maintenance purposes. So it's going to continue to reside in multiple systems. And these systems are going to be managed by multiple departments. That's just how our business works. One department is going to manage their system one way, another department is going to manage their system another way. The quality of data in these systems is important today and long term, right? It's going to reduce our risk when making risk-based decisions, and it's going to increase our efficiency with day-to-day tasks and projects. So how do we achieve this? Consistency through integration and accuracy through traceability. So we ensure consistency by integrating our departments, our data systems, by aggregating our data, and we achieve accuracy by aggregating our documentation and tracing our data points back to that reliable documentation. So I'll leave you with a challenge. I would just ask you to consider the way that the PSI is currently managed at your facility. Do you have a strong MOC system? Are you not a part of it? Maybe you don't know. Maybe you just manage one part of a system. But I would challenge you to compile the information for a single equipment type within a single process unit into a spreadsheet from all these different data sources, and maybe include whether you have documentation or not, and determine if you have discrepancies or deficiencies within these systems. And I think the results may surprise you. You may start to find out that you've got deficiencies or discrepant data where you thought it wouldn't have existed before. So thank you for your time, and Pam, I guess we can open it up to questions at this point.
Okay, thank you, Scott. Can you hear me?
Yes.
Great. Okay, first question. Does this software need to be customized for the client, or is it a generic software?
This software would be customized based on the systems that you use. So I would say it needs to be customized to talk to certain systems. So maybe if you use SAP and someone else uses another maintenance type software, this software would need to be customized to speak to SAP as opposed to the other one.
Okay, thank you. How do you handle integration in a company that is not operating off the same platform?
I'm sorry, could you repeat that?
Yes. How do you handle integration in a company that is not operating off the same platform?
I don't know that I still fully understand it, but I would say integration to me is aggregation of data, accessibility. I think all of those things we can make possible, whether it's electronically, whether it's physically. Integration really is just trying to achieve consistency by making sure that everyone in a company is able to see the same information in the same sort of way and make decisions based on the same information and knowing that that information is accurate.
Okay, thank you. For this ARTS system, is there an automated change log generated as this data is updated by any of the departments or connected systems?
So within ARTS, you're able to download download information from different systems as many times as you choose. So the reports that you can generate can show you things that changed since your last download. So when you generate reports based on downloading information, you're able to see information that has changed from this time to the next time.
Okay, thank you. Should a company validate all PSI data prior to uploading to the system? Who should do the validation?
Really, that's up to the company. The company can decide to do so, but really, while implementing ARTS, that is typically a part of the implementation effort, is to not only configure the system and configure the software, but also to validate the data. So whether that means having data technicians go through vault files, if it means field technicians that come out and go take physical pictures, really it's up to the company, but it could be done either way. If the company has those resources available to them that are able to go through those files, take those pictures, then that's great. If not, part of an ARTS project could include those things.
Okay, thank you. For this ARTS system, I'm sorry, we asked that already. What is the order of magnitude for implementing an ARTS solution?
The order of magnitude, I guess if we're talking, depends on the size of the facility and the amount of data that you have, right? There's really 3 phases to an ARTS implementation project. The discovery, configuration of the system, and initial discrepancy identifications. Then you could have that validation effort like we talked about, where you field verify, linking records to each other, and then reporting and resolution, right? So the order of magnitude depends on how much not necessarily how much configuration, how much validation do you need? How accurate is your data? Do you have any idea? Is your documentation maintained in one place, or are we going to need to send people to various locations to find it? I think the order of magnitude really depends on the way that your information has been maintained to this point.
Okay, thank you. How often is a PSM violation related to PSI management?
Well, I think PSI management really goes hand in hand with management of change, and that's kind of what we talked about in this presentation today. I think a lot of times we attribute violations or maybe releases or things like that. We attribute those back to our management of change process and not necessarily to our PSI management, where we may have made a calculation or a design error based on an MOC not being done correctly because we didn't have the right PSI. So I think ultimately we need to tie management of change to PSI management. And if our management of change fails and we don't manage and we don't update our PSI correctly, if we're managing it properly, if we're able to validate data on a month-to-month basis, if we're able to compare our data, then even when our MOC process fails, we're able to, through our PSI management process, we're able to catch those errors.
Okay, thank you. Are there other items that are considered by industry as PSI that are not in the OSHA PSM listing?
Sure. Considered by the industry, I would say different sites, different companies would maintain different information and call it PSI. It really depends on where you're at. You may call your corrosion monitoring efforts at your site PSI, where another site wouldn't. But OSHA, of course, is the driving factor, and that's why we looked at specifically OSHA requirements today, because company to company, site to site, what you consider PSI, what you would keep maybe in a package with all of your process safety information, may be a little above and beyond what OSHA calls PSI.
We get a lot of input from our regulatory department that we need to have a paper backup to ensure accessibility of important information during audits or emergency situations. Have you ever seen an electronic-only system challenged by a regulatory body?
I have not. I have not seen that challenge. In fact, a lot of the places that I've been, they have been trying to get out of the paper system and just purely manage things electronically. So I've not been a part of a challenge like that before.
Okay, thanks. Within the ART system, is there a way to link to documents or reports from the connected systems in addition to the ability to upload the documents directly to ARTS?
Not at this time. So the way things are linked into ARTS at this time, things are uploaded directly onto the server and maintained in ARTS.
Okay, thank you. How does the integration of multiple systems into ARTS work? Does an ARTS rep work with the company to compile the data, or does the company do the loading itself?
An ARTS rep would work with the company. So the first step, like we talked about, would be configuring the system, and so that would be done on the ARTS side. And that would mean configuring the system to talk to whatever systems that company wanted it to talk to. Once things have been integrated and once that initial configuration is complete, sure, it's possible for that site to be trained on uploading that data month to month or week to week or however often they choose to do so, and uploading the associated documentation. So I would say initially, integration, configuration is managed on the ART side, but it is there is the potential, the ability to hand that responsibility off to the company.
Thanks. How is data from drawings like I'm sorry, this just disappeared from my screen. How is data from drawings like PNIDs brought into the ARTS software?
Well, drawings that are configured with blocks. So if your PNID system, if you use blocks and not just text on your drawings, text and lines, these blocks we can extract data from these blocks, and we can determine what we would call an attribute based on the block name and things like that. So as long as the drawings are what we call smart, where they use blocks and not necessarily just text and lines, then that's how the data is extracted.
Okay, how is data updated across platforms? If a change is made in one system, will it automatically be updated in ARTS?
No, that update will come with an upload of ARTS. So if that upload happens monthly, if you make a change today and you don't do an ARTS upload until the 31st of the month, then ARTS would not be, that data system would not show that data update until that upload occurs. Now, you could change master values in ARTS prior to that. So you could have a value that we say this is the correct data, and that can be maintained day to day through just doing a simple change in ARTS. But the systems themselves will not show the data upload or data updates until that upload occurs.
Okay, thank you. Do you have any case examples that you can share that indicate how much time it takes to implement ARTS, say on some type of parameter such as hours per 100 equipment items?
You know, I don't have that information right offhand, but that information is definitely available. We have done multiple ARTS updates, but again, I think it would go back to trying to just speak to it off the top of my head is difficult because it depends on ultimately what do you want to see out of ARTS? How many attributes are you tracking? How good is your documentation now? How available is documentation? How much field time is involved in evaluating things? But we have available to us data from all types of efforts, from efforts where there was no data available and 100% field verification required, to efforts where the data was pretty good and limited field verification was required. But I can't speak to those numbers off the top of my head.
Okay, thanks. If your part of the company is using a Documentum system and one part is using LiveLink, how can you show data across the company since systems are not compatible?
Well, since systems are not compatible, I think that what ARTS would try to do would show the data from those different systems and how they compare at the data point, right? So even if the systems aren't necessarily compatible, ARTS would show you, if you want to know these are the attributes that I want to know they're validated, ARTS can show you these are validated. And they show you that based on there's documentation available that validates this data. The system shows you that maybe this system contains the document, this system doesn't. This is where they disagree. But ultimately, what ARTS can do is show you this is the value, this is the data, and it's validated based on this.
Okay, thank you. How do you integrate PSI management with existing MOC workflow?
Well, I think we got into that a little bit earlier. I think MOC, you can have MOC errors that can be caught through PSI management. So I think they automatically work together as soon as you start a PSI management effort like we're talking about here. So as soon as you begin to compare your data frequently on some sort of frequency, as soon as you begin to compare different systems that should be being managed by your MOC system, you're automatically integrating the two. You're able to identify, I've got deficiencies here. I'm not getting the documentation that I should be getting when we're making these changes. Maybe I'm not getting my alteration reports, and ARTS is telling me that this data was changed, but I've got no report to tie it to. That would point right back to your MOC system. Are we getting stuff handed over to us the way that we should? It would also tell you I'm updating my inspection software, but we're consistently failing to update our PFDs properly or our P&IDs properly. So I think by just doing the work, by starting to manage your PSI in this manner, it's automatically going to point right back to your management or change system.
Okay, are changes made in other software automatically populated into ARTS on a live basis, or do you have to manually run something to look for changes?
This would point back to the upload. So they would not be updated automatically. So if you make a change in SAP right now, that change will, and you've already integrated this at your site, that change will not automatically show up in ARTS. You will have to do your upload on some frequency to maintain that.
Okay, thanks. Are there minimum IT systems functionality or software requirements to utilize ARTS?
No, not that I'm aware of, other than the things we talked about, like with P&IDs, maybe the way that the information is entered in some cases. Just using AutoCAD as an example, when we don't enter things in a certain way, if we don't use blocks and things like that, then that can present challenges. But to my knowledge, there's no minimum software requirements.
How long does a data update take?
A data update, depending on the amount of data you have, I've been at sites with lots of equipment, with thousands and thousands of pieces of equipment. And an update for a refinery or something like that with, say, 10 to 15,000 pieces of equipment probably takes half a day to a day to upload all the data from those systems. And it, of course, depending on how many systems you want to do it from. That's using maybe 5, 6, 7 different systems, and that large number of pieces of equipment, probably half a day to a day to upload ARTS.
Okay, do you recommend a full-time person to manage the system and ensure departments update?
Yes. Based on the experience that we've had, I would recommend a full-time person to manage the system. Maybe not necessarily full-time, but a person to manage the system. A person that can run the reports that you need to run, a person that can perform the uploads that you need to perform. Also a person that, if you want to see your data updated day to day, if you want to see a master value that today reflects what's in the field and you don't want to wait on an upload, then you can do that, and you need a person to do that. And it's as simple as making an update to another system, but that person would just go in and physically change a master value to say this is the value. You also you have repair reports. You have things that are maintained, repaired, changed, that include more documentation that you didn't have in the first place. That documentation needs to be uploaded. What we call annotation within ARTS is how you trace a value back to a document. That needs to be physically done. So when you bring in a document, you need to annotate that value. You need to say this MAWP is 150 because we can trace it right back to this piece of equipment and show it for everyone to see. So there's day-to-day things that come along with it that I would recommend a person to implement this.
Thank you. If we need field verification, what are the credentials of the people you would send?
The people we would send have experience in refinery type settings, in gas plant type settings, and these people would have experience with P&IDs, experience in updating P&IDs, creating P&IDs, gathering information from various types of equipment like PSVs, exchangers, pressure vessels. They would also, by having the experience in a refinery and gas plant type setting, it gives you the safety experience needed, of course, to perform these types of activities because there's lots of risk associated with being in a refinery at all. So, yeah, I would say plot plans, P&IDs, equipment types.
Okay, thank you. Should a site have a dedicated PSI procedure, or should PSI management be merged with MOC procedure?
I would recommend a PSI procedure, and I say this because you want a procedure that tells you what you consider PSI, why you should consider it PSI, that references your OSHA requirements, that tells you what PSI should look like, where it's maintained, and I don't think you'd want to merge that with your MOC system or procedures. I think you want to keep the two separate, but allow the two processes as you manage them to work together.
Okay, thanks for that answer. I'm sorry, but that's all the time we have for questions today. So if your question was not answered, please send it to producer@aiche.org, or you can stop by Providence's booth at AICHE's spring meeting and PCPS next week. So now on behalf of the American Institute of Chemical Engineers and all who attended today, I'd like to thank Scott Kindy for this very informative presentation. Thanks also to our participants for your cooperation and thoughtful questions. Please visit aiche.org to replay this webinar or to view and sign up for our many others. Goodbye, and we hope to see you again in a webinar soon.